Hello everyone. So for today, we are going to discuss the chapter 7 or IP addressing. Also, we are going to discuss the three subtopics: the 7.1 IPv4 network addresses, 7.2 IPv6 network addresses, and 7.3 net connectivity verification.
Good day, everyone. I am Therese Faithian Met, and in connection to our topic in Chapter 7, IP addressing, let's have 7.1 IPv4 network addresses. In here, we will tackle about binary and decimal conversion, the IPv4 address structure, IPv4 unicast, broadcast, and multicast, and types of IPv4 addresses. Binary and decimal conversion. IPv4 addresses consist of a string of 32 bits divided into 4 sections called octets. Each octet contains 8 bits or 1 byte separated with a dot. Let's take a look at the figure in our presentation. 192.168.10.10 is an IP address that is assigned to a computer. So what we see under that is the 8 bits or 1 byte. Conversion between binary to decimal. So let us take a look to the chart for us able to understand. It has positional value, binary number, calculate, add them up, and result. So let's in positional value we have 128. So to calculate them by 128. In 64 by 64, 32 by 32, 1/6 by 16, 8 by 8, 4 by 4, 2 by 2, 1 by 1. Let's move on to IPv4 address structure. We have network and host portion. So again, let us take a look to the figure in our presentation. So able to know what is the network portion. It has iyang gibahin. So in network portion, na diri ang 192.168.10.10. So the host portion, we will see it in the last. So host portion, that is the 10. The subnet mask. The subnet mask is 255.255.255.0. Logical A and D. So what is the network address for graphics? It would be that the IPv4 together with the network portion. Prefix length. What is the prefix length for the graphics? It would be the subnet mask. Network host and broadcast addresses. So let us figure out asa na sila. Asa ang network address, asa ang range of valid host, and broadcast address. So as I understand, the network address would be that the 192.168.10.10. Range of valid host is that 10. And the subnet mask is 0. Range, okay, so the broadcast address would be all of the figure from IPv4 address to subnet mask. Let's go on to IPv4 unicast, broadcast, and multicast. So in here, we have IPv4 addressing assignment to a host. We have static, type in manually, and dynamic host configuration protocol, if you are familiar with that. The IPv4 communication, it has unicast. Unicast send packets from one host to an individual host. Broadcast send packets from one host to all the hosts in the network. Multicast send a packet from one host to a selected group of hosts in the same or different network. Which types of communication are the graphics on the right? So let me guess, in the first figure, it may it may look like a dynamic host configuration protocol. So the second figure or graphic is, I guess it is broadcast. And the last graphic is multicast. Uh, as I understand, it is selected group of hosts in different networks. Let's go on to the types of IPv4 addresses. Public and private IPv4 addresses. Private addresses are not routed over the internet. Private addresses would be 10.0.0.0 or 8 or 10.0.0.0.0 to 10.255.255.255 and 172.16.0.0 or 12 or 172.16.0.0 to 172.31.255.255. Another is 192.168.0.0 or 16. Or we can say 192.168.0.0 to 192.168.255.255. It usually uses one or two bigger numbers. Special user IPv4 addresses. With that, it has loopback addresses. 127.0.0.0 8 or 127.0.0.1 to 127.255.255.254. In linked local addresses or automatic private IP addressing or APIPA addresses are 169 and 2 that 169 that 254.0.0 or 16 or 169.254 169.254.0.1 to 169.254.255.254. So let's have testnet addresses. And that is 192.0.2.0 or 24 or 192.0.2.0 to 192.0.2.255. So it has 24 bytes. And as most is the classless addressing. In classless addressing, there are CIDR, allocated IPv4 addresses based on prefix length. Last one is assignment of IP addresses. Again, the types of IPv4 addresses are public and private IPv4 addresses, the special user IPv4 addresses, classless addressing, and assignment of IP addresses.
Hello, in 7.2 IPv6 network addresses, the topics that I will be discussing are the following: IPv4 issues, IPv6 addressing, types of IPv6 addresses, IPv6 unicast addresses, and IPv6 multicast addresses. IPv4 issues. The need for IPv6, depletion of IPv4 address space, and Internet of Everything. Without IPv6, user experience would eventually be impacted. Programs would begin to slow down and devices would have a hard time communicating with each other, impacting things like internet speed and services like voice over IP and web conferencing. IP4, IPv4 and IPv6 coexistence. Dual stack IPv4 and IPv6 on the same network. Tunneling IPv6 packets inside IPv4 packets. Translation IPv6 packet is translated to an IPv4 packet and vice versa. IPv4 and IPv6 must coexist for some number of years, and their coexistence must be transparent to end users. If an IPv4 or to IPv6 transition is successful, end users should not even notice it. A dual stack device is a device with network interfaces that can originate and understand both IPv4 and IPv6 packets. IPv6 addressing. IPv6 address representation is through x colon x colon and so on, where x represents 4 hexadecimal values. The IPv6 address size is 128 bits. The preferred IPv6 address representation is x colon and so on, where each x is the hexadecimal values of the 8 16-bit pieces of the address. Apply the rules to simply these IPv6 addresses. Rule number 1 is omit leading zeros. It is a one way to shorten IPv6 addresses to omit leading zeros. Rule number 2 is omit all zero segments. The second rule for shortening IPv6 addresses. IPv6 address types. The types of IPv6 addresses are unicast, multicast, and anycast. Unicast addresses identify a single interface only, while multicast addresses identify a group of interfaces in such a way that a packet sent to a multicast address is delivered to all of the interfaces in the group, and anycast addresses identify a set of interfaces in such a way that a packet sent to an anycast address is delivered to a member of the set. IPv6 prefix length indicates the network portion. Format is IPv6 address slash prefix length, and the prefix length range from 0 to 128. Typical length is by 64. The prefix length in IPv6 is the equivalent of the subnet mask in IPv4. However, rather than being expressed in 4 octets like it is in IPv4, it is expressed as an integer between 1 through 128. Common types of IPv6 addresses: unicast addresses, unique internet routable addresses, configured statically or assigned dynamically, link to local unicast addresses, communicate with other IPv6 enabled devices on the same link. Device creates its own link local address without DHCP server. And the unique local addresses, unique local unicast, used for local addresses within a site or between a limited number of sites. Structure of an IPv6 global unicast addresses. Global routing prefix. The global routing prefix is a typically hierarchically structured value assigned to a site, a cluster of subnets or links. The subnet ID is an identifier of a link within the site. The interface ID is used to identify an interface on a link. Interface IDs are required to be unique within a subnet prefix. Subnet ID. The subnet ID is used by routers to determine the best route between subnetworks. Interface ID. The interface ID identifies an interface of a particular node. An interface ID must be unique within the subnet. IPv6 hosts can use the neighbor discovery protocol to automatically generate their own interface IDs. Static configuration of a global unicast addresses. Dynamic configuration. Dynamic configuration is the ability to change the behavior and functionality of a running system without requiring application restarts. SLAAC or SLAAC, or the Stateless Address Auto Configuration, the preferred method of assigning IP addresses in an IPv6 network. SLAAC or SLAAC devices send the router a request for the network prefix, and the device uses the prefix and its own MAC address to create an IP address. DHCPv6, or the Dynamic Host Configuration Protocol version 6, is a network protocol for configuring Internet Protocol version 6 or the IPv6 host with IP addresses, IP prefixes, default route, local segment MTU, and other configuration data required to operate an IPv6 network. Link local addresses. In computer networking, a link local address is a network address that is valid for only for communications within the network segment or the broadcast domain that the host is connected to. Dynamic or static. What is the difference between a dynamic and static IP address? When an IP device, when a device is assigned a static IP address, the address does not change. Most devices use dynamic IP addresses, which are assigned by the network when they connect and change over. Verifying IPv6 address configuration. The Show IPv6 Interface command displays IPv6 information about an interface. Assigned IPv6 multicast addresses. All IPv6 multicast addresses share the prefix of FF00 double colon /8. This way you can tell at a glance if an IPv6 address is intended for multicast or not. And scope: 1 for node, 2 for link, 5 for site, 8 for organization, and E for global scope. Solicited node IPv6 multicast addresses. A solicited node multicast address is an IPv6 multicast address used by the Neighbor Discovery Protocol to verify whether a given IPv6 address is already used by the local link or not through a process called DAD or duplicate address detection.
Let's go on to 7.3 connectivity verification. We will tackle about the ICMP and testing and verification. ICMP v4 and ICMP v6. In that, there are the host confirmation, destination or service unreachable, time exceeded, router redirection. Another is ICMP v6, router solicitation and router advertisement messages. With that, the messaging between an IPv6 router and an IPv6 device. The router solicitation message and the router advertisement RA message. Next is, and together with the solicitation and router advertisement message, we have messaging between IPv6 devices. The neighboring solicitation message and neighbor advertisement message. Last is the duplicate address detection, or DAD. Let's go on to testing and verification. We have ping and tracer route. So ping, it has testing and local stack. The 127.0.0.1 for the IPv4, or the ratio of 1 IPv6. The testing connectivity to the local LAN, and the testing connectivity to remote. In tracer route, there is testing the path round trip time RTT, and IPv4 TTL, and IPv6 hop limit. That would be all the topic connection in the chapter 7 IP addressing.